Hello, geometry students. In this lesson, the concept of a two-way table, which basically is a table of information that's got different variables in it. It's called two-way because you can either make the table this way, focusing on a person's gender or sex, or you can make the person this way, the table this way, focusing on whether they said yes or no to a question that you might have asked. So it is a table comparing two related data sets. The yeses and the nos is one set, the male versus the female is another. In this example, the 15, each individual cell represents the number of people who met both conditions. So in this cell 15 is the number of females who said yes, for example, yes, I prefer Coke versus Pepsi, or something like that. So the number of people in each individual cell. There's also what's called the marginal distributions. That's because it's in the margins. We'll add those numbers up. So look at this first one. The table shows the responses of 20 people to a question about whether they like broccoli. So 3 people who are both children and who said yes. 8 people were children who said no. 7 people were adults who said yes, and 2 people were adults who said no. The first thing I need to do on this problem is I need to get what's called the marginal distribution, meaning I need to know how many people said yes. Well, 3 adults and 7 children for a total of 10. I need to know how many people said no. 8 and 2, that's 10 again. How many people that I surveyed were children? 8 and 3 is 11. How many were adults? 7 and 2 is 9. These should both add up to 20. 10 plus 10, 10 yeses, 10 nos, 20 people. 11 children, 11 adults, 9 adults, total of 20. So the marginal distributions is what I need first. And now I'm going to go ahead and find some probability. Find the probability that a person does not like broccoli. Well, probability is what you want over total possibility. I want someone who does not like broccoli. That's going to be the 10 no's out of the total number of people. So 10 out of 20, or 1/2, do not like broccoli. Well, what's the probability if I pull a person at random, that person is an adult? Well, there are 20 people that I'm looking at, and of those 20 people, 9 of them are adults. So what's that? 45%? I don't know. 45%. It looks like I've switched to decimals. So we'll switch to decimals also. The probability of an adult is these 9 people divided by the total number of 20. On this one, you see I have the marginal distributions filled in. So I'm going to keep on going. What's the probability of a child who likes broccoli? This means I'm going to go into the table and find an individual cell. There are 3 people who are children who like broccoli. That's what I'm looking for. I want the number of people who are children and who like broccoli. That's 3 out of a total number of 20. In my group of 20 people, only 15% were children who like broccoli. How about on this other one? Again, I'm going into the table. I'm going to look for an individual cell, an adult who said no, an adult who is no broccoli. That's going to be those 2 people. So that 2 out of 20. In my group, there were only 10% of the people who fell into the category of adults who do not like broccoli. That's not to say that all adults. That's just to say among this group of 20, there were only 2 who fell into that category. Well, keep on. Find the probability a person likes broccoli given that it's a child. Well, this is a conditional probability, but if you have a two-way table, it actually is a little bit easier. If I'm telling you the person is a child, I am only looking at that row. So I'm going to have to erase this in a minute, but I don't care anything about these people. I'm only looking at this highlighted yellow row. Given among these 11 people, what's the probability that a person likes broccoli? Well, what conditional probability says is that I'm no longer looking at this total of 20. I'm only looking at 11. So my denominator has changed because I'm only looking at those 11 people. And of those 11 people, how many of them like broccoli? Well, 3. So in my sample, 27% of children like broccoli. Among children, 27% of children like broccoli. That's not 27% of everybody. It's just 27% of children like broccoli. All right, well, what's this other one? It says, find the probability of a child given that the person likes broccoli. These are not the same thing. In this case, I'm looking at only the people who said they like broccoli. I'm only looking at this column here. That means this other column doesn't exist. I'm only looking at these 10 people. So given that a person likes broccoli, among the 10 people who like broccoli, what percentage of them were also children? Among these 10 people, only 3 were children. 30. Notice these are not the same. They could be. It's just that they're asking different things. So if I'm looking at a given, it just means that I'm talking about a different group of people. How about this last one? It's continuing on. An adult given that the person likes broccoli. So given that a person likes broccoli means I'm only looking at the people who said yes. Among those people who said yes, what percentage were adults? Given that a person likes broccoli, the 10 who said yes, how many of them were adults? How about the other way? Given that the person is an adult, I'm looking at just that column, or excuse me, that row. So among those people, among the 10 people who are adults, among the 9 people who are adults, what percentage of them also like broccoli? Given that a person is an adult, what's the probability that they like broccoli? Notice the 7s are the same, but the denominators are different. So if you're looking at only adults, there's a 77% chance. I'll call it. It actually rounds up to 78% chance. But if you're only looking at people who like broccoli, only 70% were adults. Given that the person's an adult, 78% like broccoli. And that's two-way tables.